talk. So yeah, good evening everyone. My name is Jaydeep and I'm part of the Cassandra team at Uber. Today, my co-presenter Runtian, who is also a part of the Cassandra team at Uber. Both of us are going to talk about a recent addition to Apache Cassandra, which is CEP-37, and that is basically an automated repair scheduler that has been recently added to the Cassandra. Here is the high-level agenda. I will talk about why we need repair, operational pain points, how CV37 helps, and how it works in Q&A. So yeah, I won't too much, kind of talk about repair because it has been one of the most widely discussed topics, in Apache Cassandra. But at a high level, Apache Cassandra is an eventual consistent database. So when you kind of do mutations, they are kind of guaranteed to be propagated to quorum number of replicas. But there might be a case where, um, some replicas might miss it. So repair is the mechanism that is required to kind of make all the replicas in sync. So all in all, basically repair is very essential for database to perform and Apache Cassandra to kind of serve the consistent database. So given we have seen repair is very important, so let's see what has been powering repair today, right? So if you look at the left hand side, then kind of Cassandra users, and on the right hand side there are pretty famous frameworks and tools, and there are kind of custom schedulers designed and developed by individual companies. So overall, we can see there was a gap. There was not a blessed kind of version out for everybody to use, and everybody were kind of are developing their own kind of mechanism. So kind of some of the work was kind of reinventing the wheel. Um, so with repair, there are so many operational challenges, right? One is like, if we have to integrate some of the frameworks, then, everybody uses their own control plane. So integration itself is kind of, going to take time and nightmare. Second is like, if we have to run repair as a separate deployment, then the Cassandra, it also kind of brings lots of, challenges in the deployment at scale. And also, if we run repair as a kind of separate container, we lose Cassandra insights like, assistable metadata and all those things. Other problems when we don't have kind of, blessed solution or in Cassandra solution, then incremental repair, which is like if you want to enable incremental repair, it is not simply kind of toggling a flag, because if you do it, it can kind of, harm clusters. So it requires a careful kind of orchestration when we want to onboard and even offboard incremental repair. So yeah. So the good news is that, CP37 that has kind of tackled so many of these problems. The first and foremost, thing as part of the automated repair scheduler is it does not require any control plane. It is simply part of the Cassandra process. So similar to how, compactions run, as soon as you start the Cassandra, the repairs will happen automatically. Of course, we need to tune compactions, then the same way this tuning can also be done. So this eliminates kind of need for any separate control plane. It's like you start a Cassandra cluster and kind of repair will work. The second is, again, in the Cassandra world, depending on the features that you use, one repair type is not sufficient. You have to use multiple repair types like full repair, incremental repair, preview repair, Paxos only repair, repair before node replacements, and also in future maybe accord repair and other repair types, right? So if we have to kind of, the framework has to be extendable and also should have the capability so that, when there are multiple repair types intersect, do you want to allow or do you not want to allow? So that kind of flexibility has been added, and it already supports 3 repair types today: full, incremental, and preview repair. So it is pretty extendable, and we can add a new repair type with very less work. And most importantly, it has been kind of designed like over the last few years. Some of us at Uber and some of the members from the open source community, we kind of collaborated on the right design and kind of contributed it as part of the CP37. And yeah, this slide talks about CEP-37 is unique in that, it was not first kind of it was first tried and tested at scale, at large, fleet, and then it has been kind of now, put to the Cassandra trunk. So in a way, it has been thoroughly tested, battle tested against various workloads, terabytes of data on a node, and different key spaces. So yeah, it is pretty mature enough for you to try out, and it has a safe rollout kind of mechanism as well. With that, I will now hand over to my co-presenter Runtian, who will do deep dive to CEP-37 internals.
Thanks, Jaydeep. Yeah, I will dive deeper into the technical details for auto repair. So let's start with configuration. So as you can see, this auto repair framework supports different type of repairs. You can configure intervals, thread counts, repair limits, SS table caps, and there are guardrails like disk headrooms, MVCDC safety, and table exclusions. So all the configuration can be set using Cassandra the YAML, or it can be dynamically tuned using node to set auto repair config command. So let's go into this to see what auto repair can actually do. The big thing here is parallel and prioritize repairs. This means if something urgent happens, you can always prioritize repairing some nodes without waiting for other repairs to finish. And for the work splitting part, the data size is looked, and it's not just looking into the token range. So this can ensure the balanced workload for every repair. As GD mentioned, this framework is super extensible. For example, within Uber's internal fork, we added the Paxos only repair with less than 100 lines of code. So yeah, within Uber, we have like 4 types of repair now. And all the coordination happens via system distributed tables. This means there's no external services or tooling needed. All the coordination happens within Cassandra. So here's the architectural overview. So each node runs a tiny repair scheduler thread, and the global repair state is persisted in the system tables, so that all the node has the consistent view of the repair state of the cluster. So each node will decide if it's turn to run repair or not. So in this way, the auto repair framework is designed to handle failures. So node restart, node topology change won't affect this repair. So you don't have to babysit repair anymore. Yeah. And for each repair type, like full repair, incremental repair, or preview repair, they run in separate lightweight threads. These threads won't interfere with each other. This means, for example, if you have a long-running full repair, and your incremental repair will go out on time, it won't be blocked by other types of repair. So this is also the reason why it's so easy to add a new types of repair. Yeah. You cannot manage something that you cannot see, right? So observability is also very important. For this auto repair framework, it provides node and cluster level repair state metrics like repair duration, success failure counts, longest unrepaired time per node, and other table level repair metrics. All those metrics are available via the native metric system provided by Cassandra. And also we have this node to auto repair stats. It can give the operator an overview of the auto repair status of the cluster. It's similar to the compaction stats no to commands. With auto repair, repairs start to feel more like compaction. Cassandra will just do it in the background. So you don't have to manage an external tool to make it work. For the most of the time, it will just run by itself. But for some special cases, you can still tune it. It's same as compaction. So this is basically how auto repair works. Yeah. Any questions?